The first concept I've already mentioned, but now I'll name it: Mendel's principle of segregation. This is to say that a given sperm or ovum, in the case of we humans and animals, has one allele per gene. That the alleles in each one of our cells is associated because they are floating there in the same nucleus and have a paired or collective impact on what that cell does in many cases. But in the sperm or ovum, each one is on its own. Therefore, 50% of your gametes have one of your alleles for that gene, and 50% of your gametes have the other allele for that gene. Therefore, when I say 50-50, I'm talking about the chance that a given gamete will have this allele or that allele. For this whole discussion, keep your eye on the ball of, for two alleles, P and Q. Just how prevalent are they in the population? They don't have to be at 50% each. The whole point of the Hardy-Weinberg equilibrium is that the default is that they stay at whatever starting point of percent that we began with, lacking any external influence. When talking about selection, it's quite easy to think about the conditions under which all the individuals of the population are reproducing. Whether some are getting eaten first before they have a chance to reproduce, or whether some have particular features in what they're passing on to the offspring that lead the offspring not to reproduce as well the next time. All kinds of things like that. It has a great deal to do with the experience of the reproducing individuals. Drift is different. Drift is concerned with what that reproductive gene pool looks like genetically that may differ from the percentages that the reproducing population actually had. How can that be different? I mean, doesn't everybody just throw their cards in insofar as they were able to reproduce at all? And the answer to that is that, first, vastly more gametes are produced by a given cohort than ever show up in the offspring. This introduces the concept of sampling error, that alleles that, for lack of a better word, were perfectly good to go into the pool of available sperm and ova for the next generation happen not to be paired up with any other allele simply because not all gametes get paired up with other gametes. And there's no particular reason to think that those unused gametes had any consistent qualities different from the gametes that did pair up. Simple minor deviation from statistically consistent effects on an individual basis is common. Typically, in a coin flip situation, the point is to avoid the gambler's fallacy, which is to think that just because you got a heads last time, that there's some sort of heightened chance to get a heads next time. If one returns to the baseline each time, for example, you didn't really win or lose any money that particular time, then the gambler's fallacy kicks in, and the hopeful head tosser will be perturbed at, over time, the number of heads and the number of tails flipped gravitate toward 50% quickly. If, however, some effect variable is involved, such as losing or gaining money, and you end up in that new condition and then do your 50-50 flip from there, then you've entered into the possibility of a drunkard's walk, which is to say, a change in the frequency of that effect variable or the magnitude of that effect variable over time, even though each individual instance of checking on progress is 50-50.